All right, so first up, we've got Andrew Kelley telling us how to build software. I first sort of met Andrew in my last year of university. We had this lab that we essentially had 24/7. It was really like 18 hours a day, but if you hid under the desks and allowed the security guards to miss you, like you just hid from them, then it was 24 hours. And so we had this like music system that they just let us wire up. We had like duct tape wiring some like speakers next to, actually, where's Kyle? Yeah, Kyle's area. And then I had like a couple massive speakers next to mine. And then we put this software that Andrew wrote called Groove Basin, and everyone on their computer could like log in, very legally download music into this database, and then we could, play around with the queue, and it was a ton of fun. And then reading about his blog post around, I'm going to go full-time on this programming language, we're like, oh, that's weird, but cool, sure. And then a few years later, I'm like, I'm bored. I want to set Groove Basin up again. And then I'm sorry, it's really badly packaged. I couldn't do it. And then I was like, maybe this Zig thing will be easier. I'm gonna play around with that. And here we are. Anyways, I'll put it up for Andrew, everyone.
Have a good one, dude. Good. Thanks. Wow. What an incredible Zen parable. That was a good drop. Well, hey everybody, thanks for coming to Software You Can Love Vancouver. This place is sweet. Make sure you check out the mountains while you're here. So I'll kick it off. This talk is called How to Build Software from Source. And probably most of you know me, but just in case, maybe this goes on YouTube later or something. Yeah, I'm Andrew Kelley. I made the Zig programming language. At the time that I created it, I was roommates with Josh, who is sitting here, and he helped me with a lot of the language design. So make sure you get a chance to talk to Josh today if you are interested in that kind of thing. Yep, I also created the Zig Software Foundation. And we have all 3 board members here today. So Josh is on the board. Sitting next to him there is Mason. Mason is also on the board, and then I'm the president. So if you have any questions about Zig Software Foundation, you have the entire board members here today. We could technically even have a board meeting if we wanted to. If there's some important task we need to figure out or something. But yeah, I've been programming for a long time, and I've always just loved open source software. I love the collaborative spirit. I like the idea of creating something that you can give away for free, and you can get stuff for free. I just maybe that is like an inner hippie in me trying to get out. Does anyone remember GeoCities? All right, come on, who did GeoCities? Yeah, like most people in this room. OK, cool. I found this on Web Archive, so it's missing kind of like the background picture, but wow. Can you imagine if you had to report Zig bugs with this form? So when I did GeoCities, there was a point in time where this magical thing happened where I had $5 a month to spend, and I was able to use HostMonster. Did anyone do the like $5 a month shared hosting? OK, yeah, like good portion, less, but still a good portion. So SSH access was so exciting because you could go in there, you could mess with the file system, you could run commands, and they had a toolchain installed. Like they had a C compiler on there. But the only, you can see a bunch of PHP stuff here, right? Like this is what you had to work with because that was popular. But I didn't know PHP, I knew Perl. So I wanted Perl. Well, and then I wanted Python. But neither of those 2 things are PHP. But I learned that you could install software locally. Like if you just learn how to use the software installation feature, you could actually just install Perl to your home folder or install Python to your home folder. And then you could use that for CGI scripts on your $5 a month when you're a teenager website, which was very exciting. So that's where I kind of figured out, like, OK, that's the prefix. This is the configuration and instructions and that kind of thing. And I feel that skill is still kind of relevant today if you do any systems programming. I mean, you don't need it because there's so many other solutions. But in so many cases, it can simplify your experience if you're willing to just learn some of these pretty straightforward tricks. All right, so here's what we're going to talk about today. There's a few different topics. Oh, wait a minute. Oh, I think I got caching in there twice. Hold on. OK, there we go. Wait. Well, I think I'm missing something. Hold on. I better open a terminal. Like apt get install. Oh, I'm in Dvorak. All right, well, hopefully that worked. OK, and there we go, dependencies. OK, so that's what we're going to talk about today. So yeah, you can learn a lot about someone by how they obtain their software. You can also learn a lot about someone based on how much they judge someone based on how they obtain their software. But OK, we like to make fun of people who do this, right? Curl to Pseudoshell. But why is this actually a problem? Like, I agree that this is not a good way to install software, but I disagree with most people's reason for why it's not good. So a lot of people would say you can't trust them. Maybe when you download the thing from curl, it's going to be bad software. But you're about to run their software anyway, so you have to trust them. That's not the actual issue, is it? So the actual issue with this method of installation is the fact that you're installing something with root. That's just unnecessary. And then also the fact that that shell script probably is going to mess with your environment variables or just put the software in a location that doesn't make sense, or it's going to overwrite. Maybe you had a different version of the program, and it's not going to respect which one should be active in which case. It's just messy. That's the actual problem with this, is it's just disorganized. And in fact, we can kind of categorize that way of obtaining software as just getting it from an upstream binary distribution. That at its core, curl to bash is just this category of stuff. And this is an OK way to get software. Like, you just get the software directly from upstream, upstream being the people who make the software. So if you go to zigling.org/download and you download a tarball from there, you are getting an upstream binary distribution. So we, the upstream, provide that. And you're getting the intended experience of Zig from our perspective of, like, this is how I think Zig should be packaged. That's one way to get software. That's fine. That's a nice way to get software. But it might not take into account your system's unique setup. So if you want to do that, you're going to use your system package manager. And in this case, you're getting the same software, but with a different intended experience. This time it's from the system maintainer's perspective. So maybe the person who packaged up the system package, they make sure that it integrates with the other packages on your system. Maybe it integrates with some servers you have running, or maybe you have a weird dynamic linker or something, and it makes sure that all those paths are working correctly. Maybe like some upstream binary distributions just don't work, because the people who made the upstream binary distribution were not aware that on NixOS, you can't hard code the dynamic linker path, for example. But there's a whole bunch of examples of this. And it's why a lot of game devs complain that it's hard to ship on Linux, because it is, because there's a lot of different ways that you have to take into account people's systems if you're providing an upstream binary distribution, which is what game devs want to do. But there's a third option of how to install software, which is directly from source. You can just install any version you want. Most importantly, if you install from source, you can edit the code. So editing the code, and then that does not give you a way to get it from upstream. And then editing the code usually does not also get you a way to integrate with your system. So directly from source lets you contribute. That's a nice feature. You can also compile for your actual hardware, take advantage of your CPU features. You can configure it exactly how you want it. So maybe an underappreciated fact is that a lot of system software is configured with choices made by the system package manager, which maybe don't agree with the choices you want. And you can make those choices if you build from source. So I think that like, which of these options is better? I think that there's a time and a place for any of these options. But I think that this one is underappreciated. And so I just want to lift it up a bit to make it on the table with the other options. So that's what this talk is about. So that was ways to obtain software. Next, let's look at Let's look at some core concepts. So I'm saying how to install software from source. And there's a lot of programming languages out there. But there's a lot of C and C++ software out there which just underpin everything else. And so even if you're trying to use, I don't know, maybe you're trying to install like the open source version of some like ChatGPT thing or the latest whatever, latest AI art thing, it probably still is going to depend on some C and C++ packages. And maybe there's some high-level system they have to help you install things. But under the hood, knowing how to build these core dependencies is useful. There's a few core concepts I want to go over, and then we'll move on. And so the first one is this configure phase. So most building from source software, you're going to have a configure phase, and then you're going to have your build phase, and then you're going to have your install phase. And so I think that where a lot of people go wrong is that they don't appreciate that the configure phase is kind of where all the decisions are made and where you should kind of notice that it won't work. Like a lot of people get stuck on the build phase, and they see an error, and then they get confused. But they didn't look at the output of the configure phase and notice that it wasn't going to do what they wanted it to do. So in this example, we're looking at the configure phase for FFmpeg. And this output's very long, and I won't show you the whole thing. But I'll go over a couple important points from it. So one thing worth noting with FFmpeg is that you could enable and disable certain decoders. You could build, even though FFmpeg is known as kind of a bulky library, you actually could build a stripped-down version of it that only has certain encoders or decoders available. That's what you can do with the configure phase. OK, pop quiz for the audience. Should we ignore this warning? Should we just go on to the build phase now? No. So a lot of people will just ignore that, and then the build won't work, and then they'll complain that it doesn't work. But there was a warning there. So if you install package config, probably you will find more packages. So that's important. OK, I also want to highlight this install prefix. So this is arguably the most important and underappreciated point of installing things from source. This is like the main option that you should think about. And this is where you're going to put the output. And there's standards for this. So the default prefix is typically /user on POSIX systems, or more recently, like user local. But this is maddening that this is the default. I don't understand why they think this is OK. So by default, they want to use root to put your software globally for every user of the system. Never mind the fact that we're all basically single users of our dev machine. But sorry, I'm getting ahead of myself. OK, we've all seen these like prefix directories, right? You got bin, you got lib, you got include, you got a few more things. But you get to pick this prefix right here. And so my point is that don't use the default. Don't put it globally. And then as soon as you just pick a prefix that's in your home folder, you don't need root anymore. You don't need root to install your software. So that just simplifies everything. So if you ever see curl to Pseudoshell, you know that they are, not only do you know that probably it's going to do something messy, you know that they don't know how to install software from source. And they're asking you to trust them with root. So that's why I don't do that. Yeah, anyway, point being, just pick a prefix that's in your home folder, and then all these problems go away. Right, oh yeah, one more thing. So you can manage multiple prefix directories. So if I install one library, for example, to this prefix, I install this one to this prefix, I can build from source a third project that just draws from both of them. Kind of like, you can think of them as kind of just like collections of software. So you could grab from this prefix and then also install to this prefix, and you're kind of building a distribution, if you will. That's what you're doing. Or you can kind of keep them all separate, and that lets you uninstall them and reinstall them separately. So managing prefixes is kind of like a superpower of building from source. If there's one takeaway, it's just kind of think about prefixes a bit more, and then everything will be simple. What about Windows? Convention is a bit different, right? So if we were, how should our application work as far as build prefixes work? Kind of flipping it around. So now we're not building software from source. Now I'm the software being built from source. How should it work? Well, you kind of have two options. So you can go with keep the prefix the same on every operating system, and Windows users are going, oh, it's a Linux thing, OK, whatever. Or you can cater to Windows users and just have the build system do something totally different on Windows. And I don't actually have an opinion on which one's better. I mean, this is how I feel when I have to make this choice. But I don't know, I think it's fair to be an application-specific choice. Raise of hands. All right, who do we have? Who's on this side? OK. 2, 3, 4, 10. OK. How about this one? OK, a lot more, actually, on this one. Yeah, OK. I think we have some game devs in the room, so I see. Yeah. Right, OK, so we got through the configure phase. Now we're ready to go to the build phase. So now we can just run make, right? Is there a problem? Yeah, unfortunately, make has terrible defaults, and you have to opt in to actually using your CPU cores, or otherwise it's just going to build single-threaded and take way, way longer than it's supposed to. OK, cool, so I'll just use the flag that opts in to actually using my hardware, right? This is the flag to opt in to using your hardware. No, this will crash your computer. That's the crash your computer flag. Because if you opt in to using your CPU cores to build faster, it just defaults to fork bombing your computer. It will not do a thread pool. It will just spawn, 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 spawn until you run out of memory, and your computer cannot handle it, and it just freezes, and you just have to hold down the power button for 10 seconds. So yeah, don't do that. You actually have to just tell it how many cores you have. Because look, listen. When they made make, they were like babies. You know, they didn't know how computers worked. It was hard. You know, I don't know. Do computers have more cores? Maybe they didn't when they made make. We can't break stuff. We can't change the defaults. So, all right. I'll digress. But yeah, you gotta tell it how many cores you have if you use make. All right. So that's the build phase. Now, traditionally, after the build phase, comes the install phase. So you built it, it worked, but you didn't put it in the prefix. So there's a whole next phase just to copy the build artifacts into the prefix. So that's where we do sudo make install, right? No, because you picked a prefix that wasn't global. So you don't need sudo. Don't do it. There's no reason to get root privileges involved. You just don't need to do it. So this is the hill that I will die on. Everyone tells you to do this, OK? Never mind the J stuff, like just keep that separate. Just do this. You can actually combine the build phase and the install phase into one, because the install target depends on the build target. And you didn't use a global prefix, so you don't need root. Why are we doing it so complicated? Just do make install. That's fine. Configure, make install. All right. So once you do make install, you've got your software in that prefix, and you can now use that as a dependency for other software. That's pretty much it for how to build stuff from source. So yeah, I came up with this list of stuff to don't, which is yeah, it's just like some gotchas. So I don't want to be too hard on people who've made these mistakes, but here's how I would describe these things. I wrote this kind of spicy title here, but I think I want to walk it back a bit. So I would actually just call these like advanced things. And I would describe something advanced as something that could make sense for an experienced person to do, but is a pitfall for a beginner. So maybe you can think of like an advanced move in a chess game where, you know, if you see someone doing that move, you know, they're either an absolute beginner or they're a grandmaster, right? And I think that's what all of these fall into the category of. So if you're building software from source, do you use the dev branch or do you use the latest bug fix release? Hopefully, we all know it's the latest bug fix release. So you know, stuff could break in the main branch. You know, be careful. Some people, This one is kind of an understandable mistake. So there's other compilers out there. Maybe I want to try to use Clang instead of my GCC installation, or vice versa. Maybe I want to use a third different compiler or something. Due to limitations that should not exist, but very much do exist, the way to make software work when you build from source is don't try to be special. Don't try to go off a weird path. Just take the path that everyone goes down. Don't be like Robert Frost. You got to take the path most traveled. And in particular, there's some problems with C++ and things like this. But you got to stick with your system's tool chain. Otherwise, you're going into advanced mode. Let's see. A lot of people will just reach for Docker or virtual machine because they just don't. For this one, I think it's kind of a lack of confidence. It's like, oh, I don't know, building from source seems hard. I'll use Docker. But you don't have to. I mean, you can. But what I'm trying to bring to the table here in this talk is you don't actually need Docker, usually, if you just know how to build stuff from source. And it's kind of faster and simpler if you do it that way. Let's see. Yeah, I've seen this one. I don't think I need to go into this one. What else? OK, oh man, I guess I'm just kind of complaining on this one. So yeah, maybe if you run into trouble, try to flip around from like the developer's perspective, because they've definitely built their software from source, so that works somewhere, and you've found a configuration that doesn't work. But make sure that the bug you report is for a configuration that is valuable. So if you, like for example, maybe you just did exactly the build instructions, but just on a newer version of the operating system. That's a good bug report. The developer wants to know, like, oh, OK, on the newer version, we need to make this change to make it work. Cool. But I've seen bug reports where someone goes, well, I tried that, but it didn't work. So then I tried all this crazy stuff. I tried turning off, I don't know, I tried emulation mode combined with this experimental configure flag, and then I also toggled 10 other options, and now I'm getting this other unrelated error, and that's the bug report I'll make. Like, maybe start with the first bug that you ran into and report that one. Yeah. I've also seen this one, so try to remember that, like, if you, like, again, the person who wrote the software, it did build for them, so you don't need to edit the code to make it build from source, usually, unless it's an advanced case. So again, all of these there's a time and a place for all of these things, but only if you know what you're doing. So when in doubt, maybe avoid these things and see if that leads you down a simpler path. All right, so that's my to-don't list. Let's see, what are we getting into next? OK. I actually want to do a bit of a demo, so I think I'm going to skip some of the more dry slides here. Can I get a time check? How much time do I have left? 15? OK. Yeah. OK, I'm going to skip a bit of dry slides here. And I'm going to see if I can maybe get into the demo I wanted to get into here. So I do want to complain about caching a little bit. So a lot of projects use make, and make uses mtime-based caching, where they say, oh, OK, so the source file has this m timestamp, and the destination file has this timestamp, which is in the past, so we're good. But if you know anything about time and physics and electronics, you'll know that it's just kind of messy. And you really can't use the greater than operation to compare times. This just doesn't really work. So I don't know if make has fixed this in the last decade. I bet they've not, because they also didn't fix the J thing. But it's totally busted. And I super recommend to read this blog later. I don't know if you'll probably forget, but maybe someone who's watching on the internet can just pause this video, go read it, because it's pretty good. It's a tricky problem. So even if you use mtime as just a piece of a data point to notice, like, OK, the time is different. We're not using greater than. We're actually just using not equals. It's still kind of bad, because some file systems have a low granularity. And You could maybe, if you had a script or just a fast human who was able to make 2 edits within 1 second, you actually would get a false you get a false positive because the file system doesn't do m times with any more than 1 second granularity. So these are problems you have to solve with a caching system. And in the context of building software from source, just watch out for these gotchas. In the context of build systems, which I'm about to get into, this is just a problem that you need to tackle, or otherwise you're not a modern build system. All right, what else we got here? Does my 15 minutes include QA?
No.
Oh, so I have 15 minutes.
Sorry, yeah, I already had it in mind for. Yeah,
OK, great. OK, I think I have time for my demo then. Great. For anyone who's been following with the Zig project, you know that I'm probably about to lead into the Zig build system. So, who here has used make? OK, I see like almost everyone. That's cool. Who here has used Ninja? Almost everyone again. OK, that's a good audience for this talk. OK, I think you probably know the difference of these things then. Yeah, I just wanted to point out that one of the main features of these tools, like why do we use make? Why do we use Ninja? Because they're very portable. They're very easy to get installed. They are in all the package managers. Well, except make's not on Windows, is it? So that's not a good choice. Ninja actually is, so that actually does work. But anyway, I think my point is that it's kind of a low bar for a build system because it's like more important that the software is available than it is good, as evidenced by CMake. So I think that's where I'm going to go there. So let me transition into talking about the Zig build system. I'll go through this a bit quickly because I do want to show you some fun stuff in the terminal, and I think that'll be worthwhile. But apologies if you already know all this stuff. I think some people will not know this, and I think that'll be worth it. So the Zig build system is provided by the Zig compiler. If you download the Zig compiler, you get the Zig build system. It's one binary. If you want to get the upstream vendor-provided distribution, that's what that looks like. So what is that? What are we up to, like 40, 60 megabyte tarball? OK. So it's trivial to install. Like compare unzipping a folder with waiting for 2 days for MSVC to install. That's pretty nice. What else? Right. It also compiles C and C++. Does this by embedding Clang and doing a lot of other stuff on top of that. It's not as simple as just embedding Clang. But you can compile C and C++ code and Swift code. Wait, sorry, and Objective-C code and Objective-C++ code with ZigCC. And it works on Windows, which I need to keep pointing out. Right, so who's written CMake code? Over half. OK, yeah. So yeah, write your build script in a real programming language. Man, I'll try to be nice to people, but I have so much trauma from CMake that it's hard for me to be nice to CMake. So I apologize to anyone who works on CMake that's watching this. I do value your work. I use it. Zig uses CMake, but I would rather use this, to be honest. So, but thank you. So I would argue that CMake is not a real programming language because here's my argument. Because if you have a semicolon in a string, it's not a string, it's an array. And that's not a real programming language. OK. So one nice feature of a Zig build system is that you can cross-compile. So we want to add more to this list, but so far the list is basically these 3. So no matter which one of these 3 that you're on, Windows, Mac OS, or Linux, you can cross-compile to the other one. And the nice thing about this is that because Zig compiles C and C++ code, this includes if maybe it's Zig code, but you can also use the Zig build system to make C and C++ code depend on C and C++ code, and then cross-compile to these other systems. So even if you only use Zig for the build system and for C and C++, you can get these benefits. Yeah. So this example, we are on Linux on this laptop and cross-compiling for ARM64 CPUs. This is cool because we're actually passing this flag QEMU. So this is using system installed QEMU, not only to cross-compile the unit tests, but run the unit tests in QEMU. And the test runner that's being run on ARM64 QEMU is communicating back up to the build runner and telling it this metadata about how much tests passed into the build system. So that's a pretty fun integration. This example is a side project arcade game that Mason and I are working on. This is an example of, again, on this laptop, building for Windows. And you can see here that in this, this is the prefix. And you can see the choice that we've made in this game for Windows. That is not a POSIX standard path. Yeah, you could even run that in Wine if you wanted to. So it's kind of fun. Right, so I mentioned like how Make uses M-time caching and how it can be problematic. And unfortunately, I don't have time to go into all those excruciating details. But that blog post does, and it's a good blog post. But the Zig build system does solve the caching problem in a pretty cool way. So among some other strategies, it samples the file system granularity and uses that to determine when an M-time is problematic, and then kind of like preheats the cache with a miss in that case. So it's pretty good. I feel like I've actually solved the problem, and I guess I'd have to do an entire talk on caching. Modius could probably appreciate that. But is that my battery power? OK. Right. So parallelism is another one. So the cache system also works with multiple Zig processes running in parallel. And in Zig, you don't have to pass J. Actually, it will use your cores if you don't do anything. So here's a little demo. I took FFmpeg, which I was showing you the configure script from earlier. I went ahead and forked it and added I ported it to the Zig build system just to try it out. Let's see how it works. So this is entirely a third-party project. It's a C project with some assembly files in there. And just one little data point. So on this laptop, I ran this test using the upstream build system. Here's how long it took. And this 16 number is correct. So that's how many cores, 8 cores plus hyperthreading. And then this is with Zig build. And Zig build is all the phases. So when you do Zig build, it does configure, build, and install all in one step. So you can see that the parallelism, the caching system, it works pretty well. And it's not super an apples-to-apples comparison. Like this one also had to do extra work, like building libmp3 lame and building libz and doing like mostly more work. So anyway, point being, like out of the box, you're going to get it's going to actually use your hardware to build your software for you. Let's see, what else? Oh yeah, I actually listed in my notes what all this is doing. So this one's actually doing all of the above: fetching dependencies, they were cached, building the build script itself, and then building the dependencies, which included an assembler, libmp3 lame, and zlib. So all that happened faster than it took the upstream one to just do a configure and install on with their build system. So stop being slow. Let's see. I think, can I get a time check?
We're almost out of, you got like total 17 minutes left.
Right, with QA, OK.
So you can cut into your QA.
OK, let me cut into the QA like maybe like 8 minutes or so, and then that'll be good. So if you want to talk about the cache system, you can talk to me one of these 3 days of the conference. I'm going to skip this content here. I wanted to show build summary. And so this is a feature of the build system. It's nice if you have kind of a complicated build graph going on. So this is for FFmpeg. And in particular, I think it's interesting that we actually had to build this NASM assembler and run it to create a bunch of these object files, which ended up getting linked into the final binary. So I don't know. I found this to be pretty helpful when I was working on porting a more complicated project over to the Zig build system. And I do apologize to colorblind folks because Stephen, thank you for opening the issue on this, but this is not colorblind friendly, and we have plans to improve that, but not done yet, sorry. So this is the Zon file that is used in the FFmpeg project. So each one of these is just another, it's another source package. And they're all on GitHub. They could be anywhere. So these are just arbitrary mirrors. The interesting thing is that the hash is a hash of the files after unpacking it. So this hash is actually not important. This URL could just be a BitTorrent or IPFS or just whatever. This hash is actually making sure that after you download this and extract everything, does it match are the files inside actually what we expect them to be? And that's after filtering them through like include directives or exclude directives. So this is the one for FFmpeg. And each one of these is just its own. These are not pushed to a centralized server. These are all source. So when you run Zig build, it's fetching all of these, and it's building them Gentoo style, right? It's doing all the work to build everything when you run it. So that's that file. The build.zig file that's using these dependencies looks something like this. So you have the first one, which is the declarative one. And then you have this one, which is the imperative one. And you can only use stuff in this code that you declared up front. So that way tools and third-party systems can know the list of possible dependencies. So that's kind of what that looks like as far as dependencies goes. And OK, so why is this better than just using what the system they already have? Well, as Matt mentioned, I've been working on this project, this music player project called Groove Basin. Shout outs to Josh, who is my co-author of this project. And in my opinion, as an open source lover, the only way that you can get contributors to join your efforts is to make it easy to contribute. And so in the Zig branch of this project, where we're kind of rebooting it, this is what the README looks like for how to build from source and how to contribute. Right? That's the holy grail, is you run one command, and it works on Windows, it works on Mac OS, it works on every system, and it doesn't matter what you have installed or don't have installed, except for the one dependency, which is Zig. So if you want more contributors, you have to make it easier to contribute. And so the point of Zig build for me is to make it easier for people to collaborate. That's the goal. And I feel that reducing the requirements to work on projects together to one command and one dependency is in service of that goal. Yeah, so that's the Zig build system. There's been a lot of changes in this release cycle. So if you've been using the latest builds of Master Branch, sorry for the breakage. I know it's been rough. If you've been using 0.10.1, you definitely want to check out the new release, which is coming out at the end of this month, hopefully. So look forward to that. I think I actually don't have time to walk you through the demo that I wanted to show, so we'll have to save that for another day. So I'll just recap, and then we'll do QA. Right. So let's recap how to build software from source. First, ask yourself, what's the best way to obtain the software? Maybe actually just getting it from your system was better, or maybe actually just downloading it straight from the horse's mouth. That's an odd English saying, but maybe that would be better. Maybe you do want to build it from source. If you do, it's actually kind of easy. So pay attention to the configure step. Manage your installed prefixes carefully. and everything will go smoothly. Oh yeah, and please, for the love of God, just don't use root. Just eliminate that from your realm of possibilities. And finally, Zig build system is pretty cool, so give it a try when 0.11 comes out. And for those watching on the internet, I'm the president of Zig Software Foundation. We're a nonprofit, 501c3. Consider using your company's sponsored donation matching to keep us funded. There's a lot of people doing excellent work who I would love to offer contracts to if we had a bit more monthly income. So with that in mind, thanks for listening to my talk.